we are going to discuss about your practical Viva section. In this practical Viva section for grade 11 and 12, volumetric analysis is a common topic. So Viva regarding volumetric analysis we'll be discussing right now along with the detailed scientific explanation. So we'll be discussing around more than 100 Viva questions, and you can surely expect many questions from them in your Viva section in your school, okay? Also in your CBSE practicals. So we are going to discuss about Viva of volumetric analysis. First question, volumetric analysis. Volumetric analysis is nothing but titration. So simply you can call it titration. What is titration? Titration is a chemical procedure in which a solution in burette and another solution in your titration flask is allowed to be reacted, which is a spontaneous redox reaction. Indirectly we are telling it's a redox reaction. Redox reaction we are undergoing, and the product of the redox reaction, by analyzing the volume of it, we can determine the concentration of unknown quantities. Concentration can be determined through this technique. This is a spontaneous redox reaction. Okay, be it acidometry or alkalimetry or iodimetry, anything. All types of titrations are redox basically, and their aim is to determine the concentration of unknown species. So that is your aim. Concentration, and concentration means what? The molarity and strength. These two are the main things. Molarity and strength we are determining, and in your grade 11 and 12 you are mainly dealing with potassium permanganate, KMnO4, potassium permanganate, and also oxalic acid we are studying, and many other types of titrations are possible, but these two are some common types of titrations: permanganometry and the acidometry titrations. Okay, so let's discuss the Viva questions. The first question is, what is a standard solution? Whenever we are answering Viva questions, we should be very thorough with what we are supposed to speak. Always include the key points, and you can frame your sentence in your own way, but the key point should be included. Our first question which we are discussing is, what is standard solution? Standard solution. I'll be writing the key points. Using this you can frame your answer. Standard solution is nothing but it has concentration fixed. So that means standard solution is a specific type of reagent solution whose concentration is known. So we can write its concentration is known to us. This is the first point you have to include in standard solution. Concentration is known, or we can say its strength is known. Strength is known. For example, in titration, we will be given particular solution, for example sodium hydroxide or any other chemical for titration purpose. We will be given that it is m by 10. M by 10 means, what is the meaning of m by 10? This is 0.1 mole per liter. 0.1 mole per liter is the concentration of your reagent for titration. So we can say that this is a standard solution. So standard solution is a specific type of reagent whose concentration is known to us. So this is the first thing you have to know about titration. Secondly, we are going to discuss about the question number 2. Second question is, what is a normal solution? Another term, normal solution. What is the meaning of normal solution? Normal means normality. Normality is defined as What is the formula of normality? Normality is defined as equivalent mass per unit volume of solution in liter. This is the standard formula of normality. Normality, molarity, molality. These are three main types of concentration terms. So whenever we say normality, it is equivalent mass by volume of solution in liter. And I have put a detailed video on normality in first chapter of chemistry. Please do watch that also. And let's define what is a normal solution. Normal solution means we are talking about a solution whose normality is 1. So 1n. 1n solution is known as a normal solution. Normality of that solution is 1. So how can we define normality? Instead of this normality, if we put 1, we are getting it is equivalent mass divided by volume of solution in liter. Volume of solution in liter. V in liters. How can we obtain 1? If the numerator and denominator we can include it as 1, we are making it as a standard fact, it is 1, then this can also be taken as 1. That is 1 equivalent in 1 liter. So we can define one normal solution is that solution whose normality is 1 and it has 1 gram equivalent. This is equivalent mass. So I will write 1 gram equivalent. 1 gram equivalent of solute dissolved in what? 1 liter of solution. 1 liter solution has normality is 1. So we can say one normal solution, or simply normal solution is that solution in which 1 gram equivalent of the solute is dissolved in 1 liter of water. 1 liter of solution. Okay, 1 liter of the solution. So that is said to be one normal solution. So this is the second thing you have to remember. What is a normal solution? Third, we are going to discuss about the third question. Third question regarding titration is actually, what is equivalent mass of KMnO4 when it acts as oxidizing agent in acidic medium? The question is equivalent mass of KMnO4, potassium permanganate, in acidic medium. What is it? What is the value? Or what? How can you calculate? What is the equivalent mass of potassium permanganate in acidic medium? That's the question. For that, you should know, whenever you are answering such type of questions, you should have an idea about the reagent potassium permanganate. Potassium permanganate, KMnO4, exists in the form of manganate ions, MnO4 minus, and potassium ions in the solution. In this manganate ion, after the reaction, after your titration, you know that permanent pale pink color is obtained, right? That is due to the formation of Mn2 plus ions, right? This is a cation. So MnO4 minus gets simultaneously reduced, right? MnO4 minus is in which oxidation state? Let's calculate the oxidation state of manganese. Oxygen is -2 and this is X. So X minus 4 into 2, 8 equal to the overall charge -1. So X equal to +7 oxidation state. So we can replace this X and write +7. So in permanganate, manganese atom is in +7 oxidation state, and after the reaction it is forming permanent pale pink color. This is pale pink color, right? This permanent pale pink color is obtained due to the formation of Mn+2 ion. Here from +7 to +2, it is actually how many electron transfer? 5 electron it is losing. 5 electron losing means this is reduction. So permanganate is actually getting reduced to Mn+2. That is MnO4 minus ion. Permanganate ion is reduced to Mn+2 ion. Okay, so this is one thing. Now let's answer our question. What is our question? What is the equivalent mass of potassium permanganate? So equivalent mass, formula for equivalent mass is molecular mass or molar mass divided by electron transferred. So what is the molar mass? Molar mass of potassium permanganate, you have to remember, it is 158. Molar mass of potassium permanganate is 158 gram per mole. This you should always memorize. So we can write molar mass is 158 divided by the electron transferred. 5 electron was transferred. So 158 divided by 5 will give you 31.6 as the answer. 31.6 approximately gram per mole. Gram per mole, or simply 31.6 is the equivalent mass of potassium permanganate. So whenever your teacher asks you what is equivalent mass of potassium permanganate in acidic medium, then you should always answer that the formula for finding potassium permanganate in equivalent mass is actually the molar mass by electron transfer. So it is 158 divided by 5 electron transferred. So it is 158 divided by 5. Enough. Sometimes they may ask you to solve it and show, then you can use the paper and find out division process. And or else you simply tell them it is 158 divided by 5. So that is clearly understood. If they ask you why it is 158 divided by 5, then you tell that it is changing from MnO4 minus 2, Mn plus 2. So 5 electron is transferred. That is the reason 158 is the molar mass divided by electron transfer is 5. So you are getting 31.6 as the equivalent mass of potassium permanganate. So this is how you answer Viva question. Okay, now let's move to the next Viva question. I'll be putting more videos regarding this titration Viva questions and other topic Viva questions, even for your other subjects also. So I will be making different parts. Okay, this is part 1 of the video. Please to make sure you watch all the videos to get full in Viva in chemistry and physics. I will also upload that. Okay, next question regarding it is, can sodium hydroxide be a primary standard? So you have to understand, this is the 4th question. What is primary standard? What is primary standard? Primary standard. Primary standard is a special type of reagent which is in the highest purity. So here you have to use the keywords highest state of purity. Second, you have to use the keywords that it is not readily reacted with atmospheric oxygen. That is, it is not, whenever you are keeping that primary standard in open container or anywhere, it will not react with atmospheric oxygen or any atmospheric gases. So atmospheric gases you can write, atmospheric gases, and it will not form unnecessary compounds. So you can say that its purity remains same throughout. It is not very reactive with atmospheric gases. That means you can use this as constant purity, or you can say its concentration is fixed. So that is one thing. And sodium hydroxide, these 2 facts you should remember. And primary standard, this is primary standard. Okay, example of primary standard is more salt, but crystalline, oxalic acid, etc. do not react readily with atmospheric oxygen, or they are in their high state of purity. So they are in their fixed concentration. So you can call them primary standard. Can sodium hydroxide be a primary standard is a question. Sodium hydroxide is NaOH. It is kept in sealed glass bottles. You know, sodium hydroxide is not a primary standard. Why it is not a primary standard? Because it can react with the atmospheric air, and it can lose the purity. That means its purity is not fixed. That's the first thing. Its purity is not fixed, and it can react with atmospheric gases, etc. Hence, we cannot say that sodium hydroxide is primary standard. So it is no. Sodium hydroxide is not a primary standard. Not primary standard. Next question is, what is the difference between molarity and molality? Molarity and molality. I hope you understood this simple question, very direct question. They generally ask in Viva questions. Okay, these things. Fifth question. Difference between molarity and molality, which does not depend upon temperature. That also is asked. So temperature also we have to talk about. Molarity, I will use capital M to indicate molarity. It is actually number of moles of solute divided by volume of solution in liter. This we know. This is a standard definition. And molality is actually number of moles of solute divided by mass of solvent. Mass of solvent. Molality. Mass of solvent in kg. This is a standard definition of it, which is more dependent upon temperature. Here you have to see that volume depends upon temperature, because whenever you are heating a gas or whenever you are heating a liquid, its volume changes. Volume changes whenever you are heating a liquid. So there will be small changes in the volume when you are heating a liquid. So this volume changes means molarity changes. So we cannot say that molarity is more suitable when temperature changes. But here mass will not change. Mass is constant. Okay. So we can say that molality will not change. So if the temperature is fluctuating, we prefer molality as the concentration term. If the temperature is constant, we can prefer anything. It's not a problem. Okay, that's one thing. Okay. Another question, seventh question. What volume of 10 molar HCl? What volume of 10 molar HCl you need to dilute with water? 10 molar HCl with how much amount of water? Water will give you, after adding water, will be giving you 1 liter of 1 molar HCl. What is this? That is 10 molar HCl you are having in a bottle. How much water you need to add? That is how much you have to add acid into water. Never add water into acid, okay? Acid only is added to water. So how much amount of 10 molar HCl, how much amount of water is required? So after the dilution process, you will be getting 1 liter of 1 molar HCl. So how do we explain that? If they are asking such a question, you have to find the volume V here. V liter. Here we have to apply the formula of dilution, M1V1 equal to M2V2. This is the dilution formula. So what is M1? First molarity, 10 into second, first volume dilution equal to second 1 molar into 1 liter. So what we are getting? V equal to 1 divided by 10, it is 0.1 liter. So we need to add 0.1 liters of water is needed for dilution. So this is what we have to note. Simple questions only, okay? So they will not ask very tough questions of numerical type in Viva, but simple questions like this can be asked. So you always remember that. Another, which is more concentrated? This is 8th question. Which is more concentrated, 1 molar or 1 molal is more concentrated? 1 molar or 1 molal is more concentrated? More concentrated. Out of 1 molar solution and 1 molal solution, which is more concentrated? So let's see what is the meaning of concentration. Concentration means where the amount of solute is more and the quantity of solvent is less. That is more concentrated, right? Concentration value, how much concentrated, how much solute in terms of the solution. 1 molar is 1 mole of solute divided by volume of the solution. right? Okay. 1 molal is actually 1 mole solute. This is molar means molarity. This is molarity. 1 mole solute divided by mass of solvent. This is volume of solution. We know volume of solution is actually density equal to mass by volume. So volume is mass by density. Mass divided by density. We know density equal to mass per unit volume. So volume is mass per unit density. So I can write mass means mass of solvent plus mass of solute divided by density. Right? So instead of this volume of solution, I can write this expression. So it is mass of solute plus mass of solvent into density. Density I am multiplying the numerator here. You see 1 is already there on the numerator, so I will multiply it here. Density. Density here we are talking about water. Water density is 1000 kilogram per meter cube. You see, because of such big fraction, we can say that the value of concentration for molar solution is more. Because here you can see the fraction has 1, here you can see 1000. Even though the denominator is different, but it will not make much difference. The numerator is so large here. That's the reason why 1 molar solution is more concentrated. So we can say 1 molar solution is more concentrated. More concentrated. Did you get that? Okay. So always remember 1 molar solution is more concentrated than 1 molar solution. 9th question. 9th question is question number 9 is what is a basicity? What is basicity of sulfuric acid? This is a question. And also define basicity. So how will you answer? Basicity means how much OH minus ion can be produced from an acid. So acid, not OH minus ion, H plus ion, okay? Acid can ionize to give H plus ions in solution. So how much amount of H plus ion can be produced? That is meant by basicity. So basicity is nothing but how much H plus ions, not OH minus H plus, because it is acid. If it is base, we call it as acidity of a base. Okay, this is 11th grade concept which we are studying again. Simple only. Okay, so sulfuric acid, we know this is sulfuric acid. S double bond O, OH, and here also OH. How much H plus it can give? So how much it can give? This H plus, this hydrogen it can ionize, right? And this hydrogen also it can ionize. So it can give HSO4 minus and 1 proton in the first reaction when it is added to water, and this HSO4 minus is nothing but this. You remove the hydrogen, so you are getting HSO4 minus. HSO4 minus can again lose one more this hydrogen and produce SO4 2 minus and proton. So how many proton is produced? 2 protons. 2H plus sorry, 2H plus is produced. If 2H plus is produced, it's basicity. Basicity is nothing but how much H plus is produced. So it is 2. So basicity of H2SO4 answer is 2. So this you have to say the basicity of H2SO4 is 2. It's a dibasic acid. Okay, this is your 90th question, and let's see another question. I am here explaining you the scientific details regarding the Viva questions. But when you are saying the Viva questions, you will have to memorize In a sense, you will have to have an idea in your mind what is the reaction and how to find basicity. You will not be getting time to write and find out anything. Okay. Another. What is the relationship? This is your 10th question. What is the relationship question we are going to discuss? The 10th question is, what is the relationship between normality and molarity? What is the relationship between normality and molarity? Let's see. What is determined by normality? Normality and what is determined by molarity? Normality is defined as the final relationship which we have to obtain is actually normality into equivalent mass is molarity into molecular mass. This is the final result which we have to obtain. So that I will explain. Molarity is actually number of moles of solute divided by volume of solution in liter. Correct? So volume of solution in liter, I can write it as number of moles of solute divided by molarity. First expression. Okay. Right? So I can say number of moles of solute, I can write it as what? Given mass by molar mass. Correct? Given mass divided by molar mass. M divided by MO. I can write like this. What is this? Simple. Small m is your given mass. MO is actually molar mass. Capital M is your molarity. And normality. Normality is defined as what? The number of equivalent, gram equivalent per unit volume. So how much gram equivalent is needed per unit volume? That is said to be normal solution. Gram equivalent divided by volume. So these two concepts you should know, and you should always memorize this equation, that is normality into the gram equivalent, that is normality into your equivalent mass is molarity into molar mass. Normality into equivalent mass is molarity into molecular mass. So this you should always keep in mind. This is your 10th Viva question. This is only result they are really asking. Okay. Next question. Next question is, why the front door of your weighing balance need to be always closed? In a chemical balance, it is always kept in a sealed glass container, like that, apparatus. Okay, why its front door should be closed? Why its front door should be closed? Because in chemistry, especially in volumetric analysis titration, your small readings are very important. Small readings changes means large result variation you will be obtaining. So you have to close the front door of the balance in order to prevent the air from your mouth or your nose during your breathing process. If that air strikes that weighing balance, it can cause error in the weighing. That is, in your weighing balance, if the air from your mouth or your nose, that air on striking the weighing balance during weighing process can cause variation in the measurements. In order to prevent that and to maintain high accuracy, you can close the door of the weighing balance. This is the basic question. And let's see, important question. What is an indicator? Simple question. What is an indicator? Indicator is a chemical substance which shows change in color at the end point of a reaction. So keywords are chemical substance and change in color. Change in color at end point. This is very important. End point is very important. What is end point? End point is a stage of chemical reaction where the reaction is just complete. So at that particular point, when the reaction is just complete, if it shows color change, so we can tell it is end point. So that especially in redox reactions, pH can change. So end point. So that's it. Indicator. Examples of indicator are phenolphthalein. Phenolphthalein, what is the color change? In acidic medium, phenolphthalein is colorless. In basic medium, it is pink. This is the color change in phenolphthalein. And another indicator is self-indicator potassium permanganate. KMnO4 is self-indicator. Self-indicator. So this is the thing. Two examples of indicators. Other examples are also present, like methyl orange. Methyl orange. Many other examples are present. We are not discussing about that in titration right now. Okay, that is one important thing. Next question is actually why the titration flask should not be rinsed. Why your titration flask should not be rinsed. What is a titration flask? Titration flask is a conical flask. I'm just drawing a simple conical flask. Just imagine this is a conical flask. This conical flask you are not supposed to rinse. Don't rinse. Why? Why you are not supposed to rinse a conical flask? Because in this conical flask you are doing the titration process. Titration process in simple sense, your redox reaction happens in this titration flask. If you are rinsing this, actually you are pouring water. H2O is you are adding when you are rinsing. So what actually happens? The water particles, even though you remove the water particles by draining it out, still the water particles will be wetting the surface of the, that is, water molecules will be present in the inner surface of the titration flask. Now when you are carrying out your reaction, the water actually dilutes the reagents. So on diluting, what actually happens? Volume of KMnO4 which you needed to use, or volume will be having error. Volume error is obtained. So if you are rinsing the titration flask, you obtain volume error. Okay, volume error means it can cause large variations in your result. So do not rinse the titration flask. This is the main idea regarding this Viva question. Okay. Then another is actually why it is customary to read the lower meniscus in case of colorless liquids and upper meniscus in case of colored solutions. Why? Important. This is the last Viva question in part 1 series which we are going to discuss. Okay. Now the rest of the Viva questions we will be discussing about titration in part 2 videos that I will be uploading in the next. Okay. Why? The question is for colorless solution in burette. In burette, we are talking about burette, okay? In burette, colorless solution if we are taking, then we are reading lower meniscus. Lower meniscus. For colored solution, we are reading upper meniscus. Why? Why, or what is the reason behind this? Because the simple reason which if we tell, that is the upper meniscus is clearly visible in case of colored solution and lower meniscus is visible in case of colorless solution. Why it is like that? The scientific reason behind this goes to capillarity. 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 Capillary rise. Capillary rise. What is capillary rise? Let's talk about colorless solution. Colorless. When you discuss about colorless solution, for example water. Let's discuss about water itself. Water is a colorless solution, right? Water. If we are taking a burette, or this is not a burette, this is just a beaker, but imagine any type of capillary tubes or anything we can consider. It's not a problem. Here I am just explaining the fact behind this. In a beaker you are filling with water. This is water. And you are introducing a capillary tube. A capillary tube is very thin tube. Or here you can consider burette also a similar one. Burette is not a capillary tube, but still you can consider for our example. Imagine this is a capillary tube in which water, we are introducing the capillary tube inside and leave it for some time. You can see that water rises into the capillary tube and it makes lower meniscus like this. Why it is like that? Because water has more adhesive force. Here you have to talk about a force known as adhesive force. Adhesive force is a force of attraction between water molecule and the other particles. So here water molecule is attracted towards the glass particles of the burette. So in the burette, if we are seeing, imagine this is a burette in a magnified view. In the burette column, imagine this is a burette column. In that you can see water molecule, if it is taken, it always forms like this. That here you can see lower meniscus is visible. Why it is forming lower meniscus? Because the water want to have more contact with the glass. So this is only possible method. So it is having more area of contact with the glass particles by making U-shaped lower meniscus. So lower meniscus small, okay, it's very less. Lower meniscus is formed in case of water because wetting property of water is more, adhesive force is more. That is why we can say lower meniscus is possible. But in case of colored solutions like potassium permanganate or mercury, like that, upper meniscus we are obtaining. Upper meniscus because they have cohesive force. Cohesive force. In case of colored solution, we are having cohesive force. Cohesive force means instead of forming the lower meniscus, they will be obtaining upper meniscus. That is, they are attracted with the same particles only. That is, potassium permanganate is more attracted towards the particles of potassium permanganate only, and it do not want to wet the glass surface. So it will not have much contact with the glass surface, and hence if we are seeing the diagram like that of a potassium permanganate or any colored solution, mercury or anything in a capillary tube, we can see it forms lower meniscus like this. This is it forms upper meniscus. This is upper, right? Upper meniscus is formed. Here angle of contact is, you can see, or the area of contact, if I say area of contact with the glass surface is less. So by minimizing the area of contact with the glass surface, it is forming upper meniscus. It do not want to touch the glass surface much. So upper meniscus is formed because it has more cohesive force of attraction. Attraction between the particles of KMnO4 and KMnO4 is more than that of KMnO4 and glass. So we can say that it is forming upper meniscus. So that is why colored solution upper meniscus, colorless solution you have to read lower meniscus. Understand? So this is the part 1 of your titration for grade 11 and 12, your Viva section, and part 2 also make sure you watch it, and we'll be discussing more questions regarding titration in the upcoming videos. So please do like, share and subscribe, and thank you.